Well, hello, Explorer. How are y'all doing today? Woo, all right. Thank you. You represent. Well, today we're going to be talking about what is spring. First thing we need to do is show the beautiful disclaimer. Isn't it a wonderful piece of artwork? Folks, if you want to take a picture of it and read it later, feel free to do so. But if you're a speed reader, you've already finished reading it, so it's great. Since I don't see any cameras up, let's get started. So, who am I? My name is Glenn. I am one of the developers at Broadcom. I work on Spring. I work on Spring Integration, Spring Batch, and Spring Cloud Task. You're saying, well, Glenn, what are those? We're about to talk about them. When I'm not doing that, I'm on the board of directors of Atlanta Java Users Group, which means I'm also one of the folks that bring you Dev Nexus, which is the largest Java conference in the US. And it is, best part, it's all volunteer driven. I'm also a Java champion when I'm not doing all that other stuff. But more importantly, this talk is not about Spring, it's about me, and my hobbies. I love to kayak, I love to fish, I love to garden, and I love to play games. And when I say that, what I mean is that sometimes when I'm coding, I think about the games that I play, and I said, you know, when I write code and I put an app into production, there's certain things that my app needs, certain skills, kind of like the characters that I build when I am playing my games. When my games are being played, my characters need, like, you know, weapons or magic or whatever that needs to be successful in their quest. My applications need those similar skills. When we talk about that, what skills are we talking about? We have to think about security. We have to protect our apps from cyber threats. Not only do we have to do that, we also have to make sure that we give them a familiar and consistent way of accessing their data, because we're not just talking about regular, relational databases. We're talking about document databases. We're talking about index databases. We're talking about graph databases. And we want to have a way in which is a consistent way to access those, because many times our apps have more than one database that they're accessing. The other thing that we need to be able to do is have our, when I'm playing a game, I have special potions. These potions basically give me the ability to move faster, heal wounds, make me more handsome. But the other thing it also does when I'm playing my games is it gives me that special abilities to maybe communicate with other people, right? So in this case, my app needs to also be able to communicate with other applications, whether it's going to be through something called Kafka, or one thing called Rabbit, or protocols like gRPC, Pulsar, even TCP/IP. Now, there's other things that I may need. I may need to be able to access RESTful interfaces so that I can actually communicate with other systems via that way. We also have a new way in which we can communicate with other systems. It's called GraphQL. And the thing is when we look at RESTful APIs, typically when you ask a question, it gives you a whole boatload of data. That means that's data transfer, that's money, that's time. So what GraphQL says, well, look, what if I can allow you to actually execute a query and get exactly what you need, reducing the amount of data you have to transfer and saving cost. The other thing is you may have heard of something called microservices. If we have microservices in our distributed environment, they have to follow the 12-factor principles. In that case, we need to be able to add that if necessary. The other thing that we have to do is we need to have our apps be able to emit metrics. These are the things that our app is doing so that we can say, hey, when it emits these metrics, it's got to emit them to something. And these are what we call observation frameworks. And these frameworks are set up so that if alerts are tripped, people are called. But they're not called when the production necessarily goes down, and they can do that. But they're meant to call the person when the problem is small, manageable, and we can find out what's going on, fix it while it's small before we have a production down. So metrics are critical. If I cannot leave this conference until I say these two characters together, AI. If I don't put them together, I get tossed out. In this case, our apps need to be able to utilize AI. Many times we don't think about it, but we've been using AI for years in our applications. But what's different is the use of generative AI and LLMs. With these generative AIs, companies are saying now, how can I help my customers with them? And not only are they putting it into their new applications, they're putting it into their existing applications. So we need to think about that. We also have to think about speed and size. Speed is critical for when we have things like serverless environments where I may just take a function and put that function out there. That function has to start fast. So that's one thing I need to think about when I build my app. The second thing, I need to start thinking about making my applications small, reducing the amount of memory that they use. And so these are things that we have to think about to have a successful application deployed, because our applications need to be put in places where they can start fast and stay small, so I can take advantage of the compute resources. The other thing is CVEs. CVEs are the security alerts. Our apps need to be kept up to date so that we can actually resist, again, those cyber threats. So I need a place that I can guarantee I can get support for things like Tomcat, Java, and the framework I choose, right? So I need one location I can do that. Now, the question, which framework does these things and more? And that's where Spring comes in. Spring is an open source framework for building scalable, maintainable Java applications. This is kind of an extra skill that Spring brings to the table. It's designed to take all these different technologies and allows them and combine them in ways that feel natural. What does that mean? It simplifies the access to each of these technologies and provides a consistent way for you to be able to access any one of them. The reason it is important is the cognitive load on the developer is ever growing. Through Spring, we reduce that cognitive load on developers, giving them a reduced learning curve and help them be able to develop their apps even faster. Now, how does the Java community feel about Spring right now? Spring is the most popular enterprise Java development framework in the world. It is also 23 years old. You're like, wait. How old? My children aren't even that old yet. Well, in that case, we need to think about it this way. Let's put a pin in it and think about what that means. At the foundation, Spring has what we call the Spring Framework. The Spring Framework is the foundation for all the projects we're about to discuss, and it's the foundation for whatever app you are building. It provides the tools that you need to be able to build an application, like dependency injection, eventing, type conversion. We think about databases, it's JDBC, transactions, JPA. When we think about testing, it provides tools, resources to basically simplify your ability to write tests. It also provides a RESTful interfaces, or ability for you to create a RESTful interface or a REST client through what's called Spring MVC, which is a part of the framework. And also, if you're writing reactive code, you can actually use Webflux for that as well. But we said, okay, we've given you this wonderful set of tools that simplify your experience of building an app. The one thing we thought about is, what if we could take it the next level higher? What if we could configure all those resources into exactly what you need? And the way that we did that is we created a project called Spring Boot. And what it does is it says, look, we're going to take an opinionated view of what you need to do to maybe create a RESTful interface. So we provide you these, what we call starter dependencies, that will auto-configure all the beans that you need, which are the components that you have to access all the things that you need to be able to run a RESTful interface. We'll configure those. The cool part about that is that you don't see any code generation. It's all done through configuration. And not only that, it gives you a series of good defaults. You're like, okay, Glenn, where do we get started? We actually use something called Spring Initializer, and we can find that at start.spring.io. From there, I can specify what tool I want to use to build my application. I can then, once I've done that, I can actually specify what language I want. I can specify what Spring Boot version I want, how I want to name my app, whether I want to deploy a jar or war. I can specify what Java version I want. And then finally, I can go in and specify, okay, what am I going to build? So I could click the Add button. I could specify what things I want to build. Maybe in this case, I want to build a RESTful interface. I say, I want Spring Web. Maybe if I want data, it says, oh, include Spring Data. So I can actually add those components that I need. Once I do that, I click the Generate button. It gives me a zip file, and I download it. I unzip that file, and my project is ready to go. Now, like we said, Spring Boot does not give you any code. It gives you configuration. But Spring Initializer will at least give us this little piece right here, which is our main, right? This is the app. This is kind of like the kickoff of our project. For me to make this a RESTful API that will say, hello world, we do the following. We add a REST controller to the top saying, hey, this is where we're going to handle our REST requests. Then what we do is we write a little piece of code that says, it's called string hello. It's going to return hello explore. And then lastly, we say, hey, at the end of your local host, I want you to have like an endpoint called hello. And when somebody hits that, I want to return hello explore. So when we run our app, we see we get localhost. 8080 is the default that Spring Boot gives us. And then we say /hello, and it gives you what? Hello explore. Now, let's go back to that 23-year-old comment. What does Spring, how does the Java community feel about Spring at this moment? And the answer is, over the last 8 years, year-over-year growth has been going up. Over the last 2 months, we've had record downloads. Since we've been tracking Spring Framework's download rate, it has gone up 25% year-over-year. What does that mean? It means that not only people are continuing to use the Spring for their application development, they're actually adding more applications using Spring to build them. This is the critical factor of Spring, is its growth, and it's because it simplifies that usage. How does it do that for each of the skills we talked about? We have projects under Spring that fit above the Spring Boot realm, and they basically, for example, when it's time for me to secure my Spring application, I'm going to use Spring Security. It gives me the authorization, the authentication, but also what it does is it says, look, we can prevent things like clickjacking, session fixation, and so much more. So when I have to secure my application, I'm going to pull in a Spring Security dependency, right? So when I need to have a database, whether it's going to be a relational, a index, a document, a graph database, I'm going to use Spring Data. Spring Data provides me a familiar and consistent way of data access. The cool part about that is it says, look, you can write one query, and no matter what type of database it is, that query will work across all those databases. But it has a special trick under its sleeve. That special trick is it says each of those databases have special skills, right? Specifically like the graph or the index or even a relational. Since we have those special skills, Spring simplifies the access to those special skills. So whether you need just that one way of being able to write one query across various types or to utilize those special skills, Spring simplifies your experience to do that. Earlier, we kind of showed you those wonderful ways in which we can communicate with other apps. Again, our apps live in a distributed environment. So what if we said that we could do something very similar to what we did with Spring Data for databases? We can do it for ways in which we communicate with other apps. Specifically, if I'm using Kafka, Rabbit, or protocols like gRPC, Pulsar, I can through Spring, the way I send and receive messages looks exactly alike. So no matter which of these I use, once I've learned one, I can reapply that knowledge to the others. But I still can access the specialized skills that each one has, and Spring simplifies that for us. So we see at the very bottom, again, let's go back to that GraphQL piece right there. Spring teamed up with the GraphQL team, and we created Spring GraphQL. Its ability to allow you to simply create a GraphQL server or a GraphQL client. When it's time for me to go in and be able to make a microservice, do I have to write all that code to make it 12-factor compliant? The answer is no. Spring Cloud simplifies the ability for you to be able to make your apps compliant to the 12 factors. Things like external configurations, service discovery, circuit breakers. It handles all that. So you can get focus on your business problem. There's one other project that's underneath that umbrella. It's called Spring Cloud Gateway. Spring Cloud Gateway says, look, what if there's one location that you could configure to say how your users route their request to the right service? That is Spring Cloud Gateway's goal. It provides not only that routing capability, it also offers the ability for you to actually go in and specify the security that you need, whether you want to load balance it, rate limit it, all that's done in one spot. It also captures the metrics of how when a person makes a request, how long did it take to get to that service and come back? That's that power of metrics we talked about earlier. But when I have to add metrics to my application itself, we have an issue. I have to code that stuff. Or I can use Spring Micrometer, and through Micrometer, what I can do is it simplifies that experience for you to be able to capture those metrics or those observations and send them to your Datadog, your Graphite, your Prometheus, these devices that are what we call observation frameworks that create the alerts we talked about earlier. So if I have to add AI to my existing Java app or to a brand new application, I can use Spring AI. Spring AI says, look, we basically allow you to integrate your APIs, your data, to the model you want to use. Now, while it is not necessarily there for you to train your models, it is there to be able to give you a familiar and consistent way of accessing no matter what model you want, while what? Accessing those special traits that each model has, because each model has special skills that they provide. And Spring says we can give you that simplified access to those. We were talking about speed. When I'm deploying a function to a serverless environment, that function can be called hundreds of thousands of times or even a million times a day. Speed startup counts. So in that case, Spring says you can natively compile your functions. And what that means is that if you natively compile your Spring functions, what that will do is they actually have that faster startup speed because of native code. And you're like, well, how does Spring help me with that anyway? We have a project called Spring Cloud Function that says, look, you get that fast startup speed if you natively compile it, but we give you the power of all the projects I just talked about. So that is a great combination. And if I natively compile my Spring application or my Java application, it reduces the amount of memory so I can put more apps into compute resources. In both cases, I reduce my cost. Finally, what we want to talk about here is CVEs. If I get a CVE, I want to go to the one company that actually offers the ability for me to get that fix from the team that actually writes it. Broadcom hosts Spring, and Spring are the folks that actually write Spring, and we're the ones that services those CVEs. We're also the ones that issue the CVEs. But not only do we give you get support through us for Spring, you get it for Tomcat and also your Java. Oh my gosh, my character changed. What happened? Sometimes when I play a game, my character changes. And the reason I change my character is because sometimes the quest mandates certain strengths of certain characters. So before, what we had was what we called an LRP, a long-running process. This long-running process starts, and it will not end until somebody like myself says, stop. In this case, we have what's called a short-lived app. A short-lived app is a batch application, like what used to be on the mainframe. Guess what? It exists on our services today and is heavily used in the world. But what it does is it starts, does its work, and when it's done, it terminates, it stops. Well, sometimes people get like, man, what I have to do is I have to go in and actually write like boilerplate code. The answer is no. I can use something called Spring Batch. And what Spring Batch says, I can configure how I want my batch run to go. And what that means is I can specify, well, I need to read from FTP and write to a database. If that's the case, it has readers and writers to be able to do that for me. So all I got to do is configure it. And I think there's like 30 or 40 different readers and writers it offers. Not only that, do I have to code the transactions? No, I configure it. When it's time for me to tell it, hey, I've been running for 5 hours on these 10 million records and it dies at record 5 million because the database chokes, you can have it pick up where it left off. It's up to you what you want to be able to do. And then lastly, what we do have is the ability to say, look, our apps, no matter whether they are short-lived or LRPs, they live in that distributed environment. Well, a number of years ago, they came up with a series of patterns, and these patterns basically said, look, these are the best ways for you to be able to communicate between various applications. It was called Enterprise Integration Patterns. It's a book about that thick. Maybe not the book you're going to bring on a summer vacation, but it's very educational. Spring said, what if we could take those patterns and make them real? So they actually created a project that implemented those patterns. So when it's time for you to utilize those patterns, Spring has simplified that for you as well. Now, I have a favor. Please take the survey. I would really appreciate it. But the other thing I want to do is, oh, wait a minute, I think I just screwed it up. You've got homework. No, you can't leave. You've got homework. I'm bringing you back to school. I covered this material really fast, and sometimes I go through it so fast you may miss something. If that's the case, come see me afterward right over here. I'll be more than glad to talk to you. You're saying, look, I need at least like 15 or 20 minutes. Can you spend that time? If we run out of time here, we schedule it. I'm here through Wednesday night. We'll schedule a time I can meet you over there and we can talk. Folks, I want to thank you for being here. Have a great day. Thank you.